Welcome back to the Deep Dive. Ready to jump into today's cybersecurity headlines?
Always.
Security arXiv is on fire today.
32 new articles.
Yep. February 6, 2025. Laser-based denial-of-service attacks. AI-driven security. The holy hour works.
Wow. Let's dive in.
Okay. One vulnerability really caught my eye. Something you might not expect. It involves a laser pointer.
Oh, that's interesting. A laser pointer.
Yeah, a laser pointer.
Hmm.
It turns out you can use a laser pointer to launch a denial-of-service attack against some types of IP cameras.
Right.
You shine the laser right at the camera.
Yeah.
And the attacker can manipulate the video compression.
I see.
It creates this huge spike in network traffic and could disrupt the entire network.
Wow. That's pretty wild. Everyday objects can be weaponized, huh?
Right. In the digital age, anything's possible. What other vulnerabilities are researchers worried about?
Knowledge-based poisoning. It's a growing concern.
Knowledge-based poisoning.
Yeah.
Particularly with the rise of AI-driven code generation.
So imagine attackers injecting malicious code into the knowledge bases that these systems rely on.
Oh,
and then this poisoned code, it could spread through countless software projects.
That's a scary thought.
Yeah.
How can we address that?
Well, security researchers are exploring different defense strategies. For instance, there's FSLH, flexible speculative load hardening. It's a way to protect against Spectre attacks.
The vector attacks.
Yeah, they exploit vulnerabilities in modern processors. They've been a major problem.
Right.
FSLH, it goes beyond the previous methods. By securing both cryptographic and non-cryptographic code, makes systems much more resistant to these attacks.
Okay. So it's a step forward.
It is.
Moving on to large language models.
Yeah.
LLMs. We're seeing more jailbreaking
Attacks.
What's that?
These attacks bypass the safety measures in LLMs. They basically trick them into generating harmful content.
Oh, interesting.
It's like a constant cat and mouse game. Researchers trying to keep up with these vulnerabilities.
Right. It just shows you how important it is
Yeah.
to have strong defenses, especially as LLMs become, more common.
Yeah. More integrated into our lives.
I read about one promising approach. Self-defense.
Self-defense.
It uses a shadow LLM
The shadow.
to monitor and prevent jailbreaking attempts
Yep.
in real time, like a security guard for your LLM.
Pretty cool.
Speaking of threats, any new developments on ransomware?
Researchers are exploring a new technique, semantic entanglement-based ransomware detection.
Okay.
It analyzes statistical patterns in execution traces.
Execution traces.
Yeah. Looking for anomalies that might point to ransomware activity.
So instead of looking for signatures, it's looking for deviations from normal behavior.
Exactly. This makes it better at adapting to those polymorphic attacks where the code's constantly changing to avoid detection.
Clever. All right, let's shift gears a bit. Talk about privacy and data protection. There's this new concept, demographic coherence, for safeguarding data privacy.
Demographic coherence.
Yeah. Can you explain what that is?
Sure. So it aims to ensure that any inferences made about individuals from data, they're consistent with overall demographic patterns.
I see.
It's about preventing privacy violations. That might come from, statistically incoherent inferences.
Oh, okay. So adding a layer of common sense to make sure the conclusions make sense with, like, basic demographics.
Right.
That's pretty neat. Another interesting development, the use of privacy tokens in deep learning.
Privacy tokens.
Mm-hmm.
Interesting.
They're derived from private gradients during training.
Mm-hmm.
And they give you a real-time assessment of potential privacy leakage.
I see.
So developers can address privacy risks proactively.
Right. Instead of relying on just post-training simulations.
Exactly. It's like baking privacy into the development process.
Yeah, I like that.
Lastly, there's an article about privacy biases in the data used to train LLMs.
Privacy bias.
Can you tell us more about that?
So privacy bias refers to the possibility that LLMs could learn and perpetuate skewed information flows from their training data. Even if the data itself isn't leaked directly, the biases it contains, they can still impact the model's output.
Oh, I get it. So even with careful anonymization, the biases can still find their way in.
Yeah. It raises some questions about how we curate data and the need to carefully assess and mitigate biases in the training data.
That's really important, especially with the growing influence of LLM.
It really underscores the importance of responsible AI development and addressing ethical considerations throughout the entire life cycle of these systems.
Couldn't agree more. That's a perfect transition to our next segment. We'll be back after a quick break to dive into cryptography and blockchain security.
All right. Cryptography and blockchain security. Where do you want to start?
Well, there's this article about a new protocol for 5G networks.
Oh, yeah, the 5G, aka HPQC protocol. It's designed to enhance security.
Right, by using hybrid post-quantum cryptography.
That's right. It addresses the threat of quantum computing by incorporating, both classical and post-quantum techniques.
So it's like a hybrid approach.
Exactly. It's about being prepared. We don't know for sure when quantum computers will be powerful enough to crack current encryption.
Right. It's better to be safe than sorry.
Definitely. This protocol is a big step towards ensuring long-term security for 5G.
Okay, that makes sense. What else is going on in the world of cryptography?
There's some interesting research on secret sharing schemes.
Secret sharing.
Yeah. This new construction, it achieves optimal share size, so it minimizes the amount of data each participant has to store.
Oh, interesting. So that makes it more efficient.
Much more. It's more practical for real-world applications.
Cool. Any news on the blockchain front?
There is, actually. One article explores a hybrid approach, combining blockchain with IPFS.
IPFS.
The interplanetary file system.
Ah, right. Decentralized file storage.
Exactly. So the idea is to leverage IPFS for storing those large data files. And then the blockchain can focus on the transactional data.
I see. So it takes some of the load off the blockchain.
Right. Improves scalability and performance. It addresses one of the common criticisms of blockchain, that it's not great with large data sets.
That's clever, using the strengths of each technology.
Exactly. It shows how powerful it can be to combine different approaches.
Okay, let's shift gears. Talk about AI and network security. I saw something about a new tool called ClariV.
Ah, yes. ClariV. It uses a variational Bayesian approach for accurately labeling malware families.
Malware families.
Yeah, it's more accurate and scalable than existing methods.
So it's like an AI detective for malware.
You could say that. It helps researchers identify and categorize different threats.
Nice. Makes sense. So what about the bigger picture, AI and network security in general?
Well, it's becoming more and more common. AI is being integrated into all sorts of systems for user authentication, encryption, intrusion detection.
So it's becoming essential.
It is. It can automate tasks, improve detection rates, adapt to new threats more effectively.
Sounds great. But I imagine there are challenges too, right?
Oh, definitely.
Yeah.
The biggest one is ensuring that AI systems are reliable, trustworthy, and explainable.
Especially in security, yeah.
We need to be able to understand the decisions these systems are making and trust them.
Absolutely. Especially when it comes to something as crucial as security.
Right.
Okay, last one in this section. AI for automotive security. Did you see that?
Yes. With cars becoming more and more connected, security is paramount. This article discusses ACTism. It's a framework for dynamic security modeling.
Dynamic security modeling.
It lets vehicles adapt their security posture based on the threats they perceive.
So it's like a more proactive defense.
Exactly. A more resilient defense
Yeah.
against those evolving cyber attacks.
So AI is helping to create smarter and more adaptable security systems for vehicles.
That's the idea. Okay, ready to dive into some of the more theoretical cybersecurity research?
Let's do it. Okay, let's look at some research on specific applications. What did you find?
Well, there's this interesting article about a new data set for intrusion detection and security research in the Internet of Things.
The Internet of Things. That's a hot topic with all these connected devices.
It is. And this data set, it's called Gotham Dataset 2025. They generated it using a large-scale emulated IoT network.
Okay, so it's a pretty comprehensive data set.
Yeah. Includes a variety of traffic, benign and malicious, covering various attack types.
Sounds like a valuable resource for researchers testing new security solutions.
Definitely. Having realistic data sets is it's essential for developing effective defenses, especially in this area.
Right, because the IoT landscape is changing so rapidly.
It is.
What else did you find?
Let's see. There's a paper on cloud security. It offers a review of secure resource management strategies, categorizes them as defensive, mitigating, and hybrid.
Cloud security is a big one. What are some of the main concerns they highlight?
Well, ensuring secure allocation and management of virtual resources in multi-tenant environments.
Okay.
And then there's, protecting against cyber threat, that target cloud infrastructure.
Right, because it's such a complex environment.
It is. And the paper explores all sorts of strategies: access control mechanisms, intrusion detection systems, encryption techniques, it emphasizes a holistic approach.
Combining different strategies.
Yeah, based on the specific security requirements.
So no easy answers, huh?
Not really. Each cloud environment is different. You need a tailored approach.
Makes sense.
Yeah.
Okay, what's the last one?
This one's about gradient leakage in federated learning.
Federated learning. That's where multiple devices train a model together without sharing their raw data.
Exactly. And gradient leakage, it refers to the possibility of extracting private information from the gradients shared during training.
So it's a privacy concern.
Right. This paper gives a good overview of gradient leakage attacks, how effective they are against federated learning, and it discusses some defenses.
So what's the takeaway? Is it a major threat?
Well, the paper argues that the threat is real, but often overstated. The attacks are constrained, fragile, they can be mitigated.
Okay, so we need to be aware but not panic.
Exactly. Understand the vulnerabilities and implement the right safeguards.
Great advice. Well, we've covered a lot today. Laser pointers, quantum cryptography, AI bias. It's clear that cybersecurity is a constantly evolving field.
It is. And this is just a snapshot. The amount of research published every day is incredible. It shows how quickly things are changing.
It's a race to stay ahead of the bad guys.
That's one way to put it.
So what stood out to you? What was the most significant development we talked about?
That's tough, but I think the research on privacy bias in AI training data is really important. It's something we need to pay attention to as AI becomes more prevalent in our lives.
It's not just about the technology itself, but also the ethics of how we use it.
Exactly. We need to make sure AI is developed and deployed responsibly and ethically, and we need to be prepared for what we don't know yet. The future of cybersecurity is uncertain.
That's for sure. But it's going to continue to be vital.
Absolutely. It's more important than ever.
Well said. Thanks for joining me on this deep dive into the latest cybersecurity headlines. Until next time, stay safe out there.